Hi guys, Clive over at BigClive.com recently did a teardown on a metal halide projector for use with fibre optic sources. I have something similar here. This is indeed designed for use with a fibre optic source. However, this is used in a slightly different setting. This is used to provide a perfectly illuminated line for a linear CCD for film scanning. I have no idea what I'm going to do with this. It is 12 volt powered rather than 240, so we've got a electronic ballast here. But it stopped working. So what I want to do is we'll have a quick look at repairing it, and then we'll see if it will still power up. This does work on rather high voltage. I believe we're talking about a kilovolt or so here. Certainly the strike voltage is a couple of kilovolts. So we need to be a bit careful with this. So if I remove this and I zoom you down as much as I can, I need to move the camera back to where it is from the big switch. You can see on that end there we've got a nerfed track. Now, I don't know that track is completely broken, but it's certainly got them warm. So what we're going to do is we're just going to have a quick clean up around there. We've got an inductor there as well. So if we just lift that inductor off, and we've got a little flake PCB material here, and I think what we need to do now is see if we've got continuity from, I'm guessing, those pins are joined together, so we need to check continuity, possibly I would say over to this cap. What we'll do, if this is fine and there's continuity, I'll flux this and we'll just overlay some solder on there. Right, we need to be on resistance and we need to be beeping. Why do meter leads always do this? And we'll just go... Everything is on silicon wires, so it wants to recoil. Incidentally, I noticed that this light source here, the connector is made by Welsh Allen, who are more well known for... That looks good. More well known for medical type things. So we've got good continuity over there. So let's have a look underneath. We don't see anything scary under there. I see no signs of any failed parts. So that could have been something else. Now I don't know that it actually stopped working, but I know that it did smoke. So what we'll do, there we go, get some flux, and we'll just overlay some solder on that track. There we go. Hopefully we're done with that. Right, what does my meter actually go up to? 1 kilovolt. Okay, so we won't really try this. So we've got that connector goes on there. Now, the 12 volt power supply in this machine was the only thing. Sorry, this was the only thing it was running, and you can see we've got two thick cables here and two thin, and what we've got here are the main supply cables and sense cables. These went back to the power supply, so the power supply knows at the point that the sense cables join that it is providing the right voltage, and it allows the power supply to take into account cabling drop. And it also looks like we've got something similar going on the back of the board, although those pads are shorted, so the power supply will be sensing at this point. Right, we will put that there. We will point that bulb away from me and away from the camera. Incidentally, halide bulbs can explode. That's always one to be aware of. And we will go there, and we will wind the current on the power supply right back. And there we go. Right, we saw something charge, but nothing has happened. So it doesn't look like there is very much of anything going on here. So undoubtedly there is more to this. I'm just changing the power supply settings gradually. So I'm now going to disconnect the power supply there, and I'm going to short out that cap. So unfortunately it looks like there's more to this, and I notice we've just lost that. That's not great. So what we'll do is we'll just quickly sort that end out. We are going to need that. To be fair, we don't have a lot going on here, although there is an awful lot in terms of transistor drivers and things. We've got a switch mode power supply, sorry, switch mode controller down there as well. So this may not actually be quite as easy to fix as we hoped. We've got current sensing happening down here as well. Let me just sort this out. Actually, you know what I'm going to do, just for now, because we aren't going to be powering this up again, is we will... Come on. Take that off, and we'll just quickly tin this. I know I'm off camera here. What have I got on the back of my hand? So that's done, ready for later. Ow, that was still molten. I now have lead-plated fingers. Right, so we've got... I use my tweezers. So we've got current sensing going on down here. So that main positive wire, let's take that off as well. Didn't land in my tea. Goes through a current sense transformer. So this is actually a lot more sophisticated than I'd have thought it was. So what side is that that's died? It's positive, so we're current sensing on the low side. That feeds that capacitor. That's a 16 volt cap, so that's obviously only designed for 12 volts as I thought. We've got another track gone. All the way in there is another track. Let's just pop that capacitor off. So quite obviously something very bad has happened here. And to be honest, I am a little surprised, because I'm sure when this failed it was being run up on one of these bench power supplies, so the scope for something really, really bad to happen is fairly low. We've not taken any pins off, no. And you can see we've got PCB track burnt in there. So what is that we've fried? Let's just double check this. So yes, so that's a positive supply to this transformer that's gone. I think we can fix that fairly easy. I think we are going to be employing judicious use of current limiting on the lab supply. Right, somewhere around here, not long ago, I had some tin copper wire. There we are. So what we're going to do, I can't zoom you down anymore, I'm afraid. That is it for now. Bear with me, let's see what we can get you a bit closer. Right, that should be a little bit better. So we want to get some solder down here onto these tracks. Also trying to watch what the camera's doing, make sure that you can see what I'm doing. this does not make for the easiest job. Right, where is it? So what we're going to do is take a look at how much we've got to bridge here, and then we'll cut this to fit. We'll get I can't do this without blocking it under my hands. That end in there. Trouble with using tin copper wire like this is the heat transfer through it is generally enough that you're going to get other things. Now the cap is solely there to try and give us a bit of extra oomph from the power supply. So the lab power supply I'm running this on has fairly meaty output caps, so I'm not overly worried about that at the moment. So we will connect that. Now the other thing is we really do not want to power this up without a load on it, because this power supply could swing up to fairly destructive voltages without any load. Incidentally, this is almost identical to what the car people know as HID headlights. I would dearly love a set for my Audi Allroad. I don't think this is going to work somehow. Now, can I move this so that if anything happens you can see it? Zoom out. We will need to put that cap back on. So we're all good. We are in current limit already, which is where we should be. And plug in. Let's give it some current. So we definitely have something wrong here. So that's drawing at 3 amps. That voltage has to be going somewhere, or current has to be going somewhere. We are isolated. What is getting hot? There's tantalums on here. What do we think of those tantalums? That's a dead short. So something somewhere. Right, so we are showing less than an ohm there. I short my leads. I'm down at 4, and if we go here, we're fairly high. It could be the power supply not helping there, so let's just double check. So we're pretty much at 0 there. And what are we at on this tan? I realise the beats will be doing your head in. We're at 0 there. Given their reputation, I'd like to lift one side of that tant. If we can, I think I might have to take the whole thing. There we go. That's not helped us. So we have a short across the main supply. We will just pop him back down, and we will have some of this. So So what have we got as possible causes for short across the main supply? We know what we're looking for now, so we can kill that, and we'll take these off again because they're only going to snap. Right, culprits for short across the supply. I'd say it's probably going to be a cap. We've got diode up here. We've got polystyrene caps all over the place. They don't normally cause a problem. The transformer is there. I wouldn't have thought any of the chips are going to be running straight off the 12 volt supply. So maybe we need to have a look at those diodes. Maybe back EMF or something killed it. Can't really get in on that diode. Yeah, the trouble is with that short like that, we can't really test it in board until we know what that short is. I'm trying to desolder the big resistor there. Let's just, can we prise that up? Nope. Right, bear with me. I need to have this, I need more hands than I've got, so I need to pull this up against me so I can get hold of everything. So I've got hold of the leg, heat it, and pull and push the board down at the same time. There's it generally leads to a situation where you need more hands, and you've got that diode has just broken. That's interesting. Now, this arrangement of diode, resistor and capacitor looks very snubber network like. And that's not helped us, so can we get onto the back of that diode now? Nothing that way. Nothing that way. Let's go on to diode mode. So that's a normal diode drop. It's not our diode there. Right, what we'll do is we will solder him back down. It's obviously, although it looks broken, it obviously isn't. Right, he's back in circuit. So we've got another diode over here. That's these pins here. Diode drop. Open, so that's fine. So what else have we got? Let's try that. That's not across the 12 volt line. Oh, you know what? That's not across 12 volts, that's not across 12 volts, but that is. I wonder if we have a regulator somewhere. So that almost feels like a regulator, that little SOT23 down there. So, what have we got going here? It's quite hard to see what's going on. So our cap is out. There's a discharge resistor across the cap. We've got current sensing going on here. What is this? This is our... So the bottom two are positive, so our negative supply is going around here, goes around to here. Various transistors there which are involved in switching whatever that is. And then we're coming down here. That's a ground there. And this all looks a bit crusty over here, but I don't think it's actually a problem. Can I see a part number on that? I cannot. Now whatever it is that's short is allowing us to pull 2 amps without breaking a sweat, which makes me wonder about this transistor. How is that held in? That's just spring clips. Let's see if we can get enough heat into the board to release that heatsink. Yep, we can. It might not tell us much, although we'll be able to see that transistor. IRFP 45N06. Ouch, that's hot. So where's my pokey stick? So we're going up to this transformer. That's our positive supply. I'm inclined to think, let's just pull that bridge we put in out, because where that fails suggests that the short is probably after the bridge. We'll put that where we can find it in a minute. So do we still have our short? No, right, nothing up until this transformer is shorted. And I think once we go to that transformer, that's it. So that's our negative, that's our positive. So the transformer is shorted to positive. Now we have another device here. Do you reckon we can be as lucky and get that one off as well? I think that's a diode, looking at it. No, I don't think we're going to get that one off. Not as easily. But that is a 2-pin device. That is a diode. So we need to go back onto diode mode. Okay, that could be okay. Diode's okay. So we've got just trying to work out how this transformer goes together now. Let's get back on beats. That's that. That's that. So we've got the bottom of the transformer is center tapped. So how are we switching that? I'm a bit confused now because I'm not sure quite what we're doing. So we're coming in, our positive comes in, there is a track that goes up, under and out to this area here, which carries our positive supply over there. Sorry, that's the negative supply goes up over there. Then we've also got this enormous track here that jumps on negative over here. We've got what looks like a snubber network here. And then this is our switching transistor. Which is driven by this here. I guess that could be short. So what we have here is a transistor that has turned into a three-way bit of wire by the looks. Let's see if we can get this out. I'm being lazy and not going and finding the desolder tool, which I may regret. I'm wondering if I have a suitable replacement for this. I'm sure this is a MOSFET, but I'm betting that our short circuit is going to disappear when we remove this, which is always going to make life more difficult. I think we're out on those. Part of the reason that I'm persisting on doing it this way is you get to learn that there are some things that the solder socket just isn't going to work with. Right, let's check those pads again now. But I think we had, and you can hear my meter is working. And now if we go between positive and transformer, not much doing there, and that's good. So what I'm going to do is put that jump back in as well before I forget about it. There we go. This looks to be our culprit. It is an RFP 45N06. Pretty sure I have them. So I'm going on the tab here because the tab is connected to there. Now that's a three-way short. The concern here is that's shorted to the base as well, or the gate. So we may have done some damage down here. There is a large resistor there. But let's just quickly poke around these transistors. Nothing, oops, sorry, I was off screen. Nothing seems to be too bad there. So what we're going to need to do is I'm going to need to go and look up what that is. And see if I've got something suitable. I think it's a MOSFET, so we should be okay. And I think once that's done, we might well be good. My concern is the damage that being shorted to the base may have done. So I'll be back in a second and I will see if I can find one of these. So I found a potential part. We just need to check it. The problem is I have absolutely loads of high power N-channel MOSFETs, and because all I do now is SMD in my own designs, it means that I have very little spare. So we should have a diode drop on one of these. That's fine. There's our diode drop. So that's gate and drain. Actually, I think it's drain, gate, and source. So we just need to get it on here. I think I am, because I am not brave, going to just tack this on the top. Sorry, my camera is pointing further down than I thought. So yeah, I'm just going to tack this on the top for now. If it works, then I'll go to the effort of sorting it all out properly. I have no idea what I'm going to do with this if this does work. If anyone's got any ideas or anyone feels that they might be able to do something with this, then by all means let me know. I'm not convinced that this will work. I'm fairly convinced this transistor is a good equivalent. My battery is about to go, but I'm not convinced totally. We'll have to. We do need to get that heatsink on. So the problem we've got here is this is a plastic tabbed device, which has a much thicker tab than the heatsink is set up for. So we will bend those up. Battery is about to fail. Maybe I can blow this up live for you before it does. We're all good. We do need to put our lights back on. One there. One there. There we go. I am not convinced, as I said. Power on. Yeah, everything is now wrapped around everything. As I say, I'm fairly sure this is going to cut out any second now, so I'm going to stop here. Start again at minimum. Right, battery did indeed run out, so let's see if we can get somewhere with this. So I want that so you can kind of see what's going on, but I don't want it to blind the camera. We'll zoom you down a little bit. I will make an admission, I have tried this. There we go. I think what we'll also do is knock off that one. We will turn off the main light like that. Just make sure that we are still set at the right voltage. And here we go. You can see it attempting to ignite. And there we go, we're lit. The bulb will now warm up. This lab power supply cannot actually supply enough power to run this. I'm current limiting at 3 amps. But as you can see, or I don't know if the camera will allow you to see, it is getting progressively brighter as it warms up. And we're fixed, I believe. So there we go. That's just stepped up brightness again. I'm going to shut this down because everything is running at the limit, and that's going to get too bright for the camera in a second. There we go, and we will put the main light back on. So that's sorted. So the last job we need to do is I just want to make sure that I can safely touch this thing. So we've got a gas discharge tube there. Turn a meter on, that would help, wouldn't it? There is no voltage there. No voltage there. So we need to just quickly pop that cap back on, which will potentially help with things. And then, yeah, this is going to really come down to I have no use for this. Does anyone else? Go back to at least make an effort to get the heatsink back on as well. I'm off camera again. Let's just get that on there. There we go. And we want to get that cap back on. So we'll pop a bit of fresh solder on. The cap unfortunately can no longer sit right down because obviously we've got the repair under here. Right, we just need to quickly check polarity. So positive is there, so our negative needs to face this way. That one's in. we should be able to get that one fairly easy. He says. That one's in, and we'll just ease that cap in, but as I say, we're not going to sit it right down because we've got that repair under there. There we go, and we'll just clean that up a little. So yeah, I've realised I'm off camera again. So yeah, I mean, if you can think of anything that you could use this for, or anything I could use it for, please feel free to let me know in the comments. But off the top of my head, and we have ignition, off the top of my head I can't think of anything I'd use this for. So yeah, any ideas, let me know. Take care.